combine your like terms. From this, we should be able to see what type or how many solutions we would have. No solution, because we have the same coefficient but different constants. So you could stop there. Aiden, make sure you're focusing. Or if we wanted to actually solve this, subtract 7x on both sides, and we have -6 equals 30, which is not a true statement. So either way, it would be no solution. Questions on that one? Number 4. Find the x-intercept of the graph. There's only one at -1, 0. This one couldn't be done on Desmos because you have to know the equation of the graph. And then for number 5, to solve for y, not the y-intercept, but for y, you're solving the entire equation to get y by itself. So subtract 3x. And divide everything by -2. So we have y equals 3 over 2x minus 4. And then I'll show those two in Desmos. Remember that you can be using Desmos on the shark bites, and your work would be did in Desmos. Okay, so I'll go start with 5 and go backwards. For number 5, if I were to type in the original 3x minus 2y equals 8, I could find what the y-intercept is, count what the slope is, positive 3 over 2, and then write that as an equation. And if they overlap, then I know I did that right. Four. And they do overlap. So that would be a good way to check yourself in Desmos. Use Desmos to solve it. And then the other one, you have to put both sides in separately. If you put them all in together, nothing would appear. But if you put them in separately, 7x minus 6 and x equals 6. You'll see that they are parallel lines. They have the same slope. They're never going to cross. They're never going to intersect, so they would be no solution. Questions on either of those? Right. Last class we talked about systems of equations by graphing. Now we're going to talk about one way to solve it algebraically using substitution. So make sure those notes are in front of you. Write down this definition and the steps. So the substitution method is a method of solving systems of equations by substituting equations within one another. The steps are solve one equation for x or y, substitute this expression into the other equation and solve for the variable, substitute your answer into the revised equation or one of the equations, and then solve for the other variable. So it's a lot of solving, substituting, solving, substituting, solving. part 1, both of these are already solved for y. So we don't need to do that part. It's already done for us. So then we're going to take one of these equations. You don't have to draw this part. So I can take this first expression and substitute it into the second equation where y is. Or I can take the second expression and substitute that where the first y is. Again, you don't need to draw that. You can if you want. But it doesn't matter which one I choose for this because it's going to end up looking like 4x minus 1 equals 2x minus 5. Rewrite that. Or vice versa. One on one side and then the other on the other. We've substituted one of the expressions into the other and now they're equal to each other. And now we could solve this by, for x by doing what?
Would you subtract 4x to the other side?
You could do that. There are different options. So if we subtract 4x and then we have to add 5, we have 4 equals negative 2x. And you could divide everything by negative 3. But because we're dealing with systems of equations, that isn't our final answer. In order for us to have a solution, it needs to have x and y. So we have to go back and type y. By putting this value into one of these two equations, it does not matter which one. So let's say I did the first one. We have y equals 4 times negative 2 minus 1. And then I could simplify that and figure out what y is. And then once I find that y value, I would put the x and the y together as an ordered pair, negative 2, negative 9. And that would be my answer. The check methods we did the other day, taking the solution, putting it into both equations, seeing if it works, will still work here. You could still check by graphing here, but you still have to show the work algebraically. Do we have any questions on that process so far? Now these other ones are not set up like this. Not both of them are solved for the same variable. One is solved for a variable and the other one is not. If you want, you could solve the other one so that it's also y equals and do this same process for all of them. But you may be creating more steps than what's necessary. But it would work. For number 2, I have an equation that's solved for y, so I don't need to solve for 1. So I'm going to take this expression, and I'm going to substitute it into the other one where y is. And then rewrite that second one. So it would look like 2x plus 3 times 6x equals negative 20. We did something like this before when we were solving equations back when we did that. And that was kind of like a foresight, I feel like that's the right word, into this. Then solve this, so 2x plus 18x equals negative 20. Combine your like terms, solve for x. So the x equals and then take that and put it back into, again, you can do either of these equations, but the easier one would be the equation that's already solved. So I could put this back into the first one. So that my y value would be negative 6, and then we could write our solution, negative 1, negative 6. questions so far? Number 3 is just like number 2, but there's just a little bit more to it. So same process. Take the expression, put it into the other one where y is. The biggest thing with substituting is substituting into the right place. If you start to substitute and you see 2 different variables, you know something is wrong, something is off. So then from there, go ahead and distribute and start to solve for x. When we get here, how do we solve this equation? We have 11x equals negative 77, divide both sides by 11. So x equals negative 7. Go back and find y. What is your y value? 2. Positive 2. So our ordered pair would be negative 7, 2. What's different about number 4? Solve for x and y. That doesn't matter. You don't need to make it solve for y. It can be solved for x. But because it's now solved for x, when we take it and substitute it, we're going to put it in for x instead of y. So when we rewrite it, it would be 2 times 4y plus 7 in parentheses minus 6y equals 12. And then solve for y. Should get y equals negative 1. Go ahead and find x once you finish solving that. And these arrows that I'm drawing, you do not need to draw that, but if it helps you visualize where is this going, you can definitely do that. What is our x value? Our solution would be 3, negative 1. Even though we solve for y first, still put it as an ordered pair x and then y. Do you have any questions, confusion about that one?
It's not about that one, it's about all of them. For number 1 is also an ordered pair.
The answer we got?
Also an ordered pairs.
So far. We'll do some that are not. Go on to the back once you finish that one. one, so all the other ones were solved, one of the equations were solved for x or for y. This one is not. You have choices. You can solve for whichever x or y in either equation, but the easier one would be the one that's by itself or has a negative sign in front of it. Everything else will give you fractions, and then you're substituting equations with fractions, and then it's likely to get messy. So you can still do any other one, but the easiest one would be the one that's by itself. So how would we get this y by itself? Subtract 2x on both sides. We have y equals negative 2x minus 2. Then everything else is the same. Take it, substitute it, solve, find what the variable is, solve, substitute and solve. We have 5x plus 3 times negative 2x minus 2 equals negative 8. Go ahead and start solving that. Some of you are watching me do this, but you should be trying to solve it on your own. Not get x equals 2, go back and double check your work. And then you should have started to put that in for y. And found what y was. What did you say? Should be 2 negatives. So as you're doing notes, if you're just copying down what I'm doing and not trying it on your own, you're not really getting the hang of it also. We are going to do one example, and then any of you guys want to see where it's a special case. So I want to say numbers 9, I know, right? 9 and 7. So 9 or 7. You guys choose 7 or 9. And we'll do one of those. Then for number 9, same as before, find the easiest thing to do would be to find the variable that's by itself and solve for that. How would we solve for that variable?
We would subtract 2x on the side.
Subtract 2x on both sides. So we have y equals negative 2x plus 18. And then we do what with that? For the other y in the other equation, yes. So that would be 6x plus plus 3 times negative 2x plus 18 equals 54. And then start to distribute. What happens when we combine like terms? The x's cancel, leaving 54 equals 54, which is what type of solution? Infinitely many. No solution would be if they're two different numbers. So you'll realize real early on that it's going to be a no solution or an infinitely many solution because the variables will cancel. Now, the variables could accidentally cancel if you substitute into the same equation. So let's say you solve this one, and then by accident you substitute it into the same equation you just solved for. The variables would cancel. But you put it in the wrong one, is why that happened. So be careful with that. Double check your answers and Desmos while you're practicing in the calculator. If you get infinitely many solutions or no solution, it can't be one solution. If you start to solve and you get an x or a y, it can't be no solution or infinitely many. So it's one or the other. Are there any other questions on this page you want to see if you go over and have questions about? Then for the remainder of class, you'll be working on one of 3 things. The rest of these practice problems on this page, your Delta Math on this that is due on Friday. If you didn't finish, which many of you have not, the Delta Math on graphing that is also due on Friday. You can be working on any of those 3 things. You're not grabbing phones. You can work together. While you guys are working, if you have questions, you can come up to me, but I will be doing course recommendations, calling you up one at a time to talk about that.